Hello everyone, and welcome back to the channel. I am so happy to see you here today. If you are new to this channel, please take a moment to subscribe, click that subscribe button, and hit the notification bell so you do not miss any of our upcoming lessons. If you find this video helpful, please give it a like. It really helps us to reach more students who need this kind of support. Also, I want to hear from you. If you have any problems or topics you're struggling with, please comment down below. I read every single comment. And for those of you who have personal questions or need one-on-one help, I will put my WhatsApp line below the video in the description box. Feel free to message me there. I am here to help you succeed. Today we are going to learn about a topic that is fundamental to further mathematics and additional mathematics. We are going to talk about calculus. This is part 1, covering limits and differentiation. This lesson is suitable for SHS 1 and SHS 2 students. Now, I know that when you hear the word calculus, you might feel very nervous. Many students find this topic challenging because it introduces new concepts and symbols. But I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. We have about 3 periods worth of content here, which is 120 minutes. So we have plenty of time to explore this deeply. I want this narration to be about 35 to 40 minutes long so that you have enough time to digest every single step. So grab your notebook, get your pen ready, and let us begin. Let us look at what we want to achieve by the end of this lesson. These are our learning objectives. By the time we finish, you should be able to understand the concept of a limit and evaluate simple limits. You will learn how to define differentiation as a rate of change and gradient of a curve. You will learn how to differentiate functions from first principles using the limit definition. This is very important. You will learn how to apply standard differentiation rules like the power rule and sum rule. You will learn how to find the gradient of a tangent to a curve at a given point. And finally, you will learn how to distinguish between average rate of change and instantaneous rate of change. That is a lot, but we will take it one piece at a time. Let us start with section 2, Introduction to Limits. What is a limit? A limit describes the value that a function approaches as the input, which we call x approaches some value. It is the foundation of calculus. Think of it like walking towards a door. You get closer and closer to the door. The limit is the door itself. You might not actually touch it, but you get infinitely close. The notation is written as limit as x approaches a pestobrote of s, of us of x equals L read as the limit of f of x as x approaches a is L. This means when x gets very close to the number a, the function f of x gets very close to the number L. There are methods for evaluating limits. Method 1 is direct substitution. This is the easiest way. You try substituting the value of it directly into the function. If you get a normal number, that is your answer. For example, limit as x approaches 2 of open bracket 3x plus 1 close bracket. You just put 2 where x is. 3 times 2 plus 1. 6 plus 1 is 7, so the limit is 7. Method 2 is factorization. This is used for indeterminate forms. Sometimes when you substitute, you get 0 divided by 0. This is undefined. It is like a traffic jam. We need to clear the road. We do this by factorizing the numerator and denominator to cancel the common term. Let us look at example 1. Evaluating a limit. The question is, evaluate limit as x approaches 3 of the fraction x squared minus 9 over x minus 3. Step 1. Try direct substitution. We put 3 where x is. Top 3 squared minus 9. 9 minus 9 is 0. Bottom, 3 minus 3, 0. So we get 0 over 0. This is indeterminate. We must simplify. We cannot stop here. Step 2. Factorize the numerator. The numerator is x squared minus 9. This is a difference of two squares. It factorizes into open bracket x minus 3, close bracket, times open bracket x plus 3, close bracket. Step 3. Simplify the expression. We write the limit as x approaches 3 of the fraction open bracket, x minus 3 close bracket times open bracket, x plus 3 close bracket over x minus 3. Notice we have x minus 3 on the top and x minus 3 on the bottom. We can cancel them out. They cancel each other like friends shaking hands. So we are left with limit as x approaches 3 of open bracket x plus 3 close bracket. Step 4. Substitute now. Now we can put 3 where x is. 3 plus 3 equals 6. Answer. The limit is 6. See how factorizing helped us remove the 0 over 0 problem? Please write that down. It is a very common question in exams. Now let us move to section 3. Introduction to differentiation. What is differentiation? Differentiation is the process of finding the derivative of a function. What does this mean? Geometric, meaning the derivative represents the gradient or slope of the tangent to the curve at any point. Imagine drawing a line that just touches the curve at one point. The steepness of that line is the derivative. Physical, meaning the derivative represents the instantaneous rate of change. For example, velocity is the derivative of displacement. If you know how position changes, differentiance tells you how fast you are moving at that exact moment. There are different notations for the derivative. If y equals f of x, the derivative can be written in different ways. Leibniz notation, dy dx. This is read as dy dx. You will see this most often. Function notation, f prime of x. Newton's notation, y dot. This is usually used for time. We will mostly use dy dx in this lesson. Now, let us move to section 4. Differentiation from first principles. This is the fundamental method of differentiation using limits. It derives the gradient formula from scratch. It is like building a house from the foundation. Some students find this hard, but I promise you, if you follow the steps, you will get it. The formula is dy dx equals limit as h approaches 0 of the fraction f of open bracket x plus h close bracket minus f of x over h, where f of x is the original function. F of open bracket x plus h close bracket is the function evaluated at x plus h. H is a small change in x. Think of it as a tiny step forward. Here is the step-by-step procedure. 1. Find f of open bracket x plus h close bracket. 2. Subtract f of x from it. 3. Divide by h. 4. Apply the limit as h approaches 0. This means wherever you see h, you make it 0. Let us look at example 2. Differentiating y equals x squared from first principles. Step 1. Identify f of x. F of x equals x squared. Step 2. Find f of open bracket x plus h close bracket. We replace every x in the function with open bracket x plus h close bracket. So f of open bracket x plus h close bracket equals open bracket x plus h close bracket squared. We need to expand this bracket. Open bracket x plus h close bracket squared equals x squared plus 2xh plus h squared. Remember this expansion. It is very important. X squared plus 2xh plus h squared. Step 3. Substitute into the formula dy dx equals limit as h approaches 0 the fraction open bracket x squared plus 2x h plus h squared close bracket minus x squared over h. Step 4. Simplify the numerator. We have x squared plus 2xh plus h squared minus x squared. The positive x squared and the negative x squared cancel out. So we are left with 2xh plus h squared. So dy dx equals limit as h approaches 0 of the fraction 2xh plus h squared over h. Step 5. Factor out h and cancel. Both terms on the top have an h, so we factor out h times open bracket 2x plus h close bracket over h. The h on the top and the h on the bottom cancel out. So dy dx equals limit as h approaches 0 of open bracket 2x plus h close bracket. Step 6. Apply the limit. H approaches 0. This means h becomes 0. So we replace h with 0. 2x plus 0 equals 2x. Answer, dy dx equals 2x. This means the gradient of the curve y equals x squared at any point x is 2x. Please write that down. This is a classic proof. Let us look at example 3. Differentiating y equals 3x squared plus 2x from first principles. This is a bit longer, but follow the same steps. Step 1. F of x equals 3x squared plus 2x. Step 2. F of open bracket x plus h close bracket. We replace x with open bracket x plus h close bracket. So 3 times open bracket x plus h close bracket squared plus 2 times open bracket x plus h close bracket, expand the squared bracket, 3 times open bracket x squared plus 2x plus 2x, plus h plus bracket plus 2x, plus h plus 2x plus 3h squared plus 2x plus 2x plus 2h. Step 3. Subtract f of x. We subtract the original function, 3x squared plus 2x. So open bracket 3x squared plus 6x, h plus 3h squared plus 2x plus 2x, close bracket, minus open bracket 3x squared plus 2x close bracket. The 3x squared cancels with negative 3x squared. The 2x cancels with negative 2x. We are left with 6xh plus 3h squared plus 2h. Step 4. Divide by h. The fraction is 6x. H plus 3h squared plus 2h over h. Every term has an h, so we divide each term by h. 6xh divided by h is 6x. 3h squared divided by h is 3h. 2h divided by h is 2. So we get 6x plus 3h plus 2. Step 5, apply limit h approaches 0. H becomes 0. So 6x plus 3 times 0 plus 2. This equals 6x plus 2. Answer, dy dx equals 6x plus 2. See, it is just algebra. Take your time with the expansion. Do not rush. Now let us move to section 5. Standard differentiation rules. Differentiation from first principles is lengthy. It takes a lot of writing, so we use rules for faster calculation. These rules are like shortcuts. Rule A, the power rule for any real number n. If y equals a times x to the power of n, then dy dx equals a times n times x to the power of n minus 1. Say this out loud. Multiply by the power, then reduce the power by 1. This is the most important rule in calculus. Rule B, the constant rule. The derivative of a constant number is 0. If y equals c, then dy to zens I dx equals 0. Why? Because a constant number does not change. Its rate of change is 0. Rule C, the sum and difference rule. Differentiate each term separately. If y equals u plus or minus v, then dy dx equals du, dx plus or minus dv dx. You just handle each piece of the function on its own. Let us look at example 4. Using the power rule, differentiate the following with respect to x. Number 1, y equals x to the power of 5. Bring down the power 5. Reduce the power by 1. 5 minus 1 is 4. So dy dx equals 5x to the power of 4. Number 2, y equals 4x cubed. Bring down the power 3. Multiply it by the 4. 4 times 3 is 12. Reduce the power by 1. 3 minus 1 is 2. So d dx equals 12x squared. Number 3, y equals 7. 7 is a constant number. It has no x. So the derivative is 0. dy dx equals 0. Number 4, y equals 3x squared minus 5x plus 2. We differentiate each term, first term. 3x squared, bring down 2. 3 times 2 is 6. Power becomes 1. So 6x, second term, minus 5x. The power of x is 1. Bring down 1. 5 times 1 is 5. Power becomes 0. X to the power of 0 is 1. So minus 5, third term, plus 2, constant. Derivative is 0. So dy dx equals 6x minus 5. Number 5, y equals 1 over x squared. This looks tricky, but we rewrite it as a power first. 1 over x squared is x to the power of negative 2. Now apply the power rule. Bring down negative 2. Power becomes negative 2 minus 1, which is negative 3. So dy dx equals negative 2x to the power of negative 3. We can write this as negative 2 over x cubed. Now, let us look at example 5, finding the gradient at a point. The question is, find the gradient of the curve y equals x squared minus 4x at the point where x equals 3. Step 1, find the derivative dy dx. Using the power rule, x squared becomes 2x, minus 4x becomes minus 4. So dy dx equals 2x minus 4. Step 2, substitute x equals 3 into the derivative. We want the gradient at x equals 3, so we put 3 where x is in the derivative. Gradient equals 2 times 3 minus 4. 2 times 3 is 6. 6 minus 4 is 2. Answer, the gradient is 2. Remember, to find the gradient, you must use the derivative, not the original equation. If you put 3 into the original equation, you get the height, not the gradient. Do not make this mistake. Now, let us move to section 6, Advanced Rules. Introduction. For more complex functions, specific rules are used. I will just introduce them here, so you know they exist. Rule A, product rule. If y equals u times v, then dy dx equals u times dv dx plus v times du dx. This is for when you are multiplying two functions together. Rule B, quotient rule. If y equals u over v, then dy dx equals v times du dx minus u times dv dx all over v squared. There is a rhyme for this. Low d high minus high d low over low squared. Low is the bottom function. High is the top function. D means derivative. Let us look at example 6 using the product rule. Differentiate y equals x squared times sine x. Let u equals x squared. Then do dx equals 2x. Let v equals sine x. Then dv dx equals cosine x. Apply the formula. U times dv dx plus v times d dx. X squared times cosine x plus sine x times 2x. So dy dx equals x squared cosine x plus 2x sine x. This is just for your information. We will practice this more in later lessons. Now, I want to warn you about common mistakes students make. Section 7. I want you to pay close attention here. These are the traps that catch students in exams. Mistake number 1. First principles, algebra, failing to expand open bracket x plus h close bracket squared correctly, or forgetting to subtract the original f of x. Correction. Write out the expansion slowly. X squared plus 2, xh plus h squared. Do not miss the middle term. Mistake number 2. Limit notation. Dropping the limit as h approaches zero notation during intermediate steps of first principles. Correction. Keep writing limit as h approaches zero until the very last step. It shows the examiner you know what you're doing. Mistake number 3. Power rule errors. Subtracting from the coefficient instead of the power. For example, differentiating 5x squared to 5x to the power of 1. Correction. Multiply the coefficient by the power. 5 times 2 is 10. Then reduce the power, so 10x. Mistake number 4. Constant terms. Differentiating a constant to 1 instead of 0. Correction. Constants disappear. They become 0. Mistake number 5. Negative powers. Forgetting to subtract 1 from a negative power. For example, x to the power of negative 2 becomes negative 2x to the power of negative 3, not negative 2x to the power of negative 1. Correction. Negative 2 minus 1 is negative 3. Count backwards on your fingers if you need to. Mistake number 6. Gradient versus coordinate. Substituting x into the original equation y instead of the derivative dy by dx when finding the gradient. Correction. Gradient comes from the derivative. Height comes from the original equation. Know the difference? Now it is time for class evaluation, section 8. I want you to pause the video and solve these in your notebook. Do not just watch. You must practice to learn. Question 1. Evaluate limit as x approaches 2 of the fraction x squared minus 4 over x minus 2. Question 2. To find the derivative of a function geometrically. Question 3. Differentiate y equals 5. X cubed from first principles. Question 4. Differentiate y equals 4x squared minus 3x plus 7 using standard rules. Question 5. Find the gradient of y equals x squared at x equals 5. Take your time. Write down your steps. Do not rush. I will wait for you. For your assignment, section 9, please do these at home. Question 1. Evaluate limit as x approaches 1 of the fraction x squared plus 2x minus 3 over x minus 1. Question 2. Use first principles to differentiate y equals 3x plus 1. Question 3. Differentiate the following with respect to x. Part A. Y equals 3 over x to the power of 4. Part B. Y equals square root of x. Hint. Square root of x equals x to the power of 1/2. Part C. Y equals open bracket x squared plus 1 close bracket times open bracket x minus 3 close bracket. Expand first. Question 4. Find the coordinates of the point on the curve y equals x squared minus 6x where the gradient is 0. Question 5 is a challenge. Use the quotient rule to differentiate y equals x over x plus 1. This last one is tricky. It uses the rule we just introduced. Do not worry if you find it hard. Just try your best. Let us do a summary of what we learned today. Section 10. We learned about limit. It is the value a function approaches as x gets closer to a specific number. We learned about derivative. It represents the gradient of the tangent or instantaneous rate of change. We learned about first principles. Dy dx equals limit as h approaches 0 of the fraction f of open bracket x plus h close bracket minus f of x over h. We learned about the power rule. D dx of x to the power of n equals an x to the power of n minus 1. We learned about the constant rule. Derivative of a constant is 0. We learned about gradient. found by substituting the x-coordinate into the derivative dy dx. We learned about product and quotient rules, used for multiplying or dividing functions. Here are some teacher's tips for breadbacks for WAEC. First principles is often the most algebraically challenging part of this lesson. Look! Through the expansion of open bracket x plus h close bracket squared slowly on the board. Emphasize that every term with an h will vanish when the limit is applied. When teaching the power rule, drill the concept of bringing the power down visually. Remind students that finding the gradient requires the derivative, not the original equation. And always check your signs. Negative powers can be tricky. I know this was a long lesson, but you have done amazingly well. Calculus can be confusing because of the new concepts, but you now have the tools to handle them. Remember, practice is the key. The more you practice differentiating functions and evaluating limits, the faster you will become. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, please subscribe and turn on notifications. I post new lessons regularly. If you have any questions about this lesson, or if there is a specific problem you're stuck on, please comment down below. I try to answer as many as I can. And remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching. Keep practicing, stay confident, and I will see you in that next lesson. Goodbye for now.